Good morning. We're going to be still in here on Tuesday, so that's 2 in a row here in the old-fashioned classroom. You guys will probably start going through Excel withdrawals since we're not going to be using the computer, but hopefully they won't be too severe. As I already mentioned, homework 14 isn't due until Thursday, May 12th, so you've got a little extra time to spend on that one. And today we're going to be talking about cost estimation. So that puts us into chapter 15 of the textbook. If you're following along with which sections of the textbook to review after the lectures, today we're covering section 1 and 2 of chapter 15. Any questions related to the announcements? Looks like we got a new projector, and whoever installed it didn't aim it right. Maybe after class you guys can get on each other's shoulders and get it aimed right, but for now we'll try and suffer through. All right. When we were talking about different types of costs, do you remember what we've already talked about as far as costs go? Variable costs and fixed cost. Yeah, I did that. That was me. Yeah. I have the control to blank the screen. It's making me power mad. Okay, so variable costs and fixed costs, right? So variable costs are those where the magnitude of the cost is affected by the level of production, and then the fixed costs are those that are unaffected by how much business or how much work your company is doing. So there's different ways to classify costs, and today we're going to be looking at some additional definitions that are completely independent of variable costs and fixed costs. It's the two can have overlap, is what I'm saying. So let's look at these. First of all, direct costs. Now, as the definition says here, that's when cost can be allocated to a specific output or work activity. So, for instance, if the question can be answered, how much of something does it take to make whatever the end product is, then most likely what we're talking about is a direct cost. So one example of a direct cost would be materials. If you are a manufacturer and you're making cases for a phone, plastic cases, then it's possible to calculate how much plastic is required to make each phone. And so then the material cost of what went into, all of the expenses that went into making a phone case, the materials is one of those direct costs, because you can say exactly how many pennies it requires in plastic to make a case like this. The same is true for these other things that are listed here, the laborer salaries. Now remember that we classified previously laborer salaries as variable costs, and we differentiated between management salaries and labor salaries, because in lots of places in the world, people who are doing the manual labor generally get paid on an hourly basis, and they won't be called into work if there's nothing to do, compared to managers who are paid maybe a monthly salary or an annual salary, and in fact they may not even qualify for any overtime pay depending on how the contract is written. So in the case of laborer salaries, then that can be considered as a direct cost, because we could say how many hours of labor went into the manufacture of each one of these cases. It's probably not, it's probably just a small fraction of an hour, but still we could allocate the amount of labor it took to make that thing. And production expenses. We could say if we have machines that are doing the injection molding, for instance, if a company has 10 of these injection molding machines, and they can collectively make 100,000 cases per hour, then it would be possible, and you know the expense of that machine, it would be possible to say how much of the machine costs can be allocated to each item. So with very careful accounting, you could say what are the specific costs. That makes it a direct cost. But some things are indirect. It's a little fuzzy to say, for instance, if we look at some of these examples, computer systems. Probably they have a computer in the factory that made the cell phone case. And we could probably look up how much that computer cost. Maybe it's a really nice desktop computer and it cost 3,000 dirhams, right? But we can't say how much of that 3,000 dirhams went into making one cell phone case, because we don't know necessarily how long that computer is going to last. We don't know what other tasks that computer is being used for besides controlling the machines that are doing the injection molding. And it would be nearly impossible to find an exact, precise, reliable number that says how much the computer systems cost that went into the manufacture of one case. And so we often classify those sort of difficult to determine costs as indirect, because it indirectly affects the cost. It's not that it doesn't affect the cost, because it does. You know, if that manufacturing facility didn't have a computer, then they wouldn't be able to do their task. And so it's not like it's an optional equipment. They have to have the equipment. But it's difficult for us to say exactly how much of X does it take to make Y. So if Y is the cell phone cases that are being manufactured, X would be the computer systems. How many computers need to be in a building to do a certain thing? Well, it's hard to say. It depends maybe how fast the users are at utilizing the computers, or how good the software is, or I think you get the idea. So let's look at some of the other things. Accounting services, because if you're having an accountant, then the accountant has to do an audit and reviewing the expenses regardless of whether there is a lot of activity or a little activity. So we could say that accounting services are probably a fixed cost, but we don't know exactly how much accounting it takes to make one unit of anything that's being produced. The same thing is true of supervisory salaries, because you can't easily allocate that to the task. You don't know how many supervisors it takes to do a certain thing. And one illustration of that is in the US, there's always this argument about like road workers. If you're ever driving by and they're fixing the road, like they're patching the asphalt, it seems like one person is shoveling and then there's 3 or 4 people standing around watching the person shoveling. It's like there's one laborer and 5 supervisors. And so you sort of scratch your head and wonder, like, how many supervisors does it take to supervise one person shoveling? And so that's an illustration of how it may be an indirect cost, because you don't know precisely how much of it is required to do a certain task. Now, instead of accounting for the specifics, what it says here in the first bullet point is it's usually recovered using standard rates and factors. What we mean is that we'll just come up with a percentage and then add that percentage on top of our direct costs, and that's how we recover for the indirect costs. And you've seen something similar to this. If you go to a restaurant, sometimes at the bottom of the bill, then it will say service charge. And maybe they're including a 10% service charge, or maybe they're including a 20% service charge. But the idea behind that service charge is that the restaurant doesn't want to have the price for the food and then separately calculate how much extra they need to charge you to bring each dish to your table. You know, it would be silly to have the food price and then the delivery price and then also charge you for wiping the table, and then also charge you because the waiter was pouring the water into your glass. And so rather than micromanage each amount, they just say, let's have a flat percentage of some other thing be charged to recover the indirect costs. And so service at a restaurant is a great example of something that's an indirect cost, because it's hard to say how many waiters you need to serve a meal. It depends on how quickly you want it and how efficient they are, how heavy the trays are, lots of different factors. So that's the distinguishing information between direct costs and indirect costs. Our final exam is going to have conceptual questions, of course, and so you should definitely understand and be able to describe the differences between those two costs. So here's a local example of indirect costs. There was an article in the paper back in December that was summarizing the Board of Trustees meeting that was being held. And the Board of Trustees for this university increased the indirect costs recovery rate from 27 to 42%. So what that means is that, let's say that a professor on campus gave a proposal to someone to do research. So there is a foundation in Qatar that supports a lot of research, and some of the faculty at AUS have been successful in attracting money. And so the university, what they do is they essentially are charging a tax on each dirham that's spent. If the professors who have that research money want to buy a machine that costs 100,000 dirhams, then the university is going to charge now, they used to charge 27%, now they're going to charge 42%. And so it actually, 142,000 would be deducted from the research fund, and 100,000 would be paid to the vendor to buy the equipment, and then the university would keep 42%. So what do you suppose is the justification? Why would the university keep a certain percentage of the research money that's spent and call it indirect cost recovery? Yeah. Mm-hmm. Excellent. Yeah, exactly right. So he says, you know, there's a lot of resources the university is providing. They're providing building space, they're providing electricity, security, insurance, and so there's a lot of expenses to providing a location for research. And so the university, in order to be able to continue to function, needs to recover those costs. And rather than individually for each research project micromanage, you know, how much they have to pay for electricity, micromanage how many square feet is being used by that research project, and so on. It's just easier for them to lump it all together as a certain percentage of all the expenses. And so whether it's money that's being spent on salary, whether it's money that's being spent to purchase equipment, they just charge a flat fee on top of it.
So is it possible for the professor to use more than 42,000 given? Like, he might use 2,000 and there will be, the university will be with that disadvantage, 8,000?
So you're saying, what if the expenses are greater than? Yeah, it's possible. So for instance, if someone was doing research that used a lot of electricity, maybe the university isn't getting enough money to justify that, but they just have this flat charge of 42%. And a lot of professors complain that their research is less expensive than 42%. So they're saying, well, if I do research in the summer, the building is going to be here anyway. So it's not like I added any additional cost because the building is just sitting mostly empty during the summer. And maybe their research actually doesn't require any equipment. Maybe it's just only them working in an office. And so they're saying the desk is already there, the computer is already there, the building, everything is already there, so I didn't add any additional expense to the university. So a lot of people complain that they're being overcharged, and probably the university used to feel like it was being undercharged, you know, like that it wasn't recovering enough, and that's why they increased the indirect cost recovery. Still at 42%, that's lower than average for universities. 27% was unheard of. That was a real bargain back when AUS was only recovering 27%, because a lot of United States universities are charging more than 50% for their indirect cost recovery. So it can be very costly to do research on campus, but you'd have expenses if you were doing it off campus. You'd have to rent an office building, and you'd have to set up utilities and everything else. So it's just a way of covering that. Other questions about indirect costs before we move on? All right. We're talking about cost estimation. And there are a couple of different ways, different methods for figuring out how much it costs to do something. Whether you are analyzing a construction project, or whether you are analyzing the cost associated with manufacturing or operating a company. There's lots of different components you have to keep track of that contribute to costs. Now, one of the ways of finding out how much things cost is called the bottom-up approach. And it's called that because what you do is you just look at the actual costs that it takes to build something or to make an item. And so you do it category by category. So you'll see here equipment and capital recovery. So if you have equipment that you paid for in year 0, then you want to be able to pay for that equipment that you made the investment on. So whatever that machine is making, you have to have a little bit of your costs associated to paying for the machine. And then direct materials are like the plastic that you're using for injection molding. It may be, if it's construction, the expenses of concrete and reinforcing steel. Okay, direct labor would be the people who are assembling the item or who are out on the job site performing the task. Maintenance and operation may be related to the equipment that you own. It may also be related to infrastructure like buildings or property that has to be maintained or security services. So these are all, you can see they've been grouped together as direct costs because they can be specifically allocated to the item and each item that's being produced. On the other hand, the indirect costs are the things that we've just been talking about, accounting, utilities, and so rather than accounting for them separately, we just add a certain percentage on top of the direct costs. Now, those two things together, the indirect and direct, you can see in this figure, conceptually it's saying you have a total cost, that's this line, and then a company isn't existing just as a charity. A company wants to make some profit, and so you would add how much profit your company wants to make, maybe as a percentage, because you know we've been talking about minimum acceptable rate of return. And so you may calculate what is your company's MAR, and then from that figure out how much your profit needs to be on top of the costs. And then those two things together, the costs and the profit, give you the price that needs to be charged for each item that's selling or for the project. And so that's the bottom-up approach. It seems very straightforward, and it's only used, though, in the real world. It's predominantly used when competition is not a dominant factor. And the reason why I say that is that this is not starting with the price, it's ending with the price. And so you only have the flexibility to dictate the price if you're making something very unique. So for instance, when Apple decides that they're going to market a new watch or a new kind of phone, because they're usually making something unique that doesn't yet exist on the market, then they can decide what the price is. You know, $4.99 or some round number that they figure people are willing to pay because it's a unique item and there's not as much competition when they first start. That's different in the top-down approach. In the top-down approach, let's assume that you're in a very crowded marketplace, maybe Dragon Mart. In Dragon Mart, you can go into one store and somebody's selling something. There's probably 50 other stores where someone's selling the exact same thing. And so there's a lot of competition. People are lowering the prices as much as they can. And so in the top-down approach, instead of looking at what are your costs as the starting point, in the top-down approach, what you look at is you say, what am I trying to make and how much could I sell it for? And so a cheaper mobile phone, you know, like a low-range Android phone that's not that unique, they would say, well, probably someone's willing to pay 500 dirhams for an Android phone that has a 5-inch screen. And so starting with that cost, then they start working downwards. They say, how much profit do we want to keep? If we're selling the item for 500 dirhams, let's say we keep 50 dirhams for profit. So then that tells them how much they have for all of the costs. And then they have to divide it up. They have to say, well, I think we need to leave a certain amount for the memory, for the processor, the battery. So they start allocating the leftover budget into these different categories. They decide how much they can afford to pay for labor. And so if they're trying to cut costs, they'll set up their factory someplace where the labor costs are very low, like China, Vietnam. Some of those countries have very, very low labor costs, and that's why they have a strong manufacturing sector. They divide up how much of it can go towards indirect costs. And so they're really trying to squeeze every last drop of value because they know that they're making a commodity, and if they try to charge 1,200 dirhams instead of 500 dirhams, then just no one will buy it. They'll find a substitute. And so that's the difference between the bottom-up approach and the top-down approach. It's sort of which method is going to be used depends on what kind of a marketplace you're in, but you can also do both simultaneously. It's sort of an iterative process sometimes, deciding how much to budget and how much an item is going to cost. And so even Apple, when they are making a new product, probably they look at things in this way. They say, we're making something new, but we don't want it to be too expensive. And so let's look at trying to shrink down some of these costs and make a target, but then we can also look at the reality of those costs and not always trying to cut things further. Any questions about these figures? All right. Now, in the project, when you were working on the analysis of your life, it would be very easy to spend a long time on estimating how much things cost. For instance, if you wanted a really detailed estimate of your food expenses, then you could go to Carrefour and you could look at each ingredient to make a salad. Instead of saying, in a week I'm going to have salad 5 times and maybe each time my salad will cost 3 dirhams. What you could have done is you could have looked at the sumac, the onion, the jarjir, a little bit of oil, some feta cheese, like each item so specifically that it takes a long time. So over here on the right side of this figure is where you have a really detailed estimate. If you spend a lot of time on an estimate, actually it's translating into spending money on the estimate, because when you're at work, your time is worth money. And so you get high accuracy if you spend a lot of time on an estimate. You can see here on the vertical axis it's saying the accuracy of estimate. So you can be within plus or minus 5% of the true cost, for instance, if you spend 3 weeks on it. But the question sometimes becomes, is the value of the improved accuracy worth more than the amount that you're likely to save by having a good quality estimate? So if you look here, a 10-minute estimate maybe leads to 30% error. So maybe that's not a good enough estimate. And so this is just illustrating a general concept that the more time you spend analyzing the data and getting quotations, the more accurate it's going to be, but it's going to be more expensive. And so you need to find a balance between the quality of the estimate and how important it is to be exactly correct. So the bottom line here, one should balance the need for accuracy with the cost of obtaining the accuracy. If someone asks you how much it costs to fly somewhere, it's very easy to get that data and to get an exact quote. But sometimes you don't need to have the exact figure for something in order to begin the preliminary planning. Here's another important figure. And one of the kinds of questions I like to give on final exams, just to see if students understand the big picture of things, is to ask students to describe a figure. Just to show some curves and say, explain what's happening with these curves. What are the trends? And so let me tell you what these trends are so that you can understand how life cycle costs are allocated. The first thing, down here on the horizontal axis, you can see that there's 2 main phases of a life cycle. We're starting at the beginning of a project all the way to the end of a project. And so the beginning phase of the project is called the acquisition phase, and that's when you have nothing yet, and you're doing the planning for the project all the way up to buying the items and then it entering service. The operation phase begins when the equipment or the project enters its useful life and goes through the end of it until when you're going to be disposing of the item. So we've talked about salvage value at the end of things in terms of getting rid of equipment. So if we now look at, for those 2 main categories, the different subcategories of each phase, the first one, needs assessment, What that means is you're analyzing the problem and you're trying to determine how big does the building need to be. You're just doing some very, very broad planning. Now, there's 3 curves here, and the first curve is the cumulative committed life cycle cost. So this curve says, at what point in the life cycle have you already agreed to a certain thing that brings you certain costs? So committed costs are different from the costs that you've actually expended. Like if you have a certain amount of money in your wallet, if you have 1,000 dirhams in your wallet, but you've already told your friend that you're going to take him for dinner tonight, and you told your parents that you're going to buy them a phone refill, and you have in your mind that you have to buy some food at the market. So just because you have it in your pocket doesn't necessarily mean that you still have a certain amount of money free, because you've already made commitments with the money. That's the difference between these 2 lines, the committed life cycle cost and the cumulative life cycle cost. So the committed costs are just that you've already made decisions that lock you in to future spending. Maybe it's a contract you have with a certain vendor. Like once you make the decision who is going to provide the steel on the job, it's not that you've already purchased the steel, it's just that once you've made that commitment, you can't save any more money on the steel. It's not like you can keep shopping around and find a lower estimate, because you have a contract, and so that money is as good as spent as far as trying to save additional funds. And that's what this top curve is, the potential for savings. You'll notice that the potential for savings is decreasing over the life of the project. And what that means is that the longer you go into the project, you can't cut costs because you've already spent the money. The total amount of money that went into the project from the very beginning, the planning, the purchasing of materials, the labor, the maintenance and operation, a project is going to cost a certain amount of money. And the longer you are into the project, the less options you have for saving the money. Towards the end of the project, most of the funds have already been spent. And so it doesn't matter how efficient you are at trying to get a really good salvage value for the equipment you're disposing of. If you paid too much for it at the beginning of the project, or if you had really high maintenance and operation costs, then those costs have already been incurred, and you don't have that much more potential for savings. And so that's why this line is decreasing. So the trend, you'll notice that once you go through design, in the design phase, you're deciding whether to choose between maybe steel and concrete. And so you're making a lot of decisions, and that's why these committed life cycle costs are going up so rapidly, is that the decisions that are being made lock you into a certain sort of glide path, lock you into how much is going to be spent. Then in the detailed design, you're making even more of those decisions. How big a structure is going to be, the square feet. You're going to start planning on how the equipment is going to be maintained, and so the curve is getting very high. And actually, once the item is being constructed, the committed costs don't go up that much because the contracts have already been signed and you've already made the decisions, but now that's when the actual amount spent is going up so quickly, is during the construction phase. And then they eventually converge to the same amount towards the end. So I'd encourage you, I've just explained this figure. I'd encourage you to look it up in the book and see what the book has to say about it, because sometimes it helps to have something brought to you from different point of views to be able to then later on explain it in your own words. Any questions about life cycle costs? If you're trying to save money, it's easiest to do it at the beginning. Have you ever heard the saying, an ounce of prevention is worth a pound of cure? So that basically means it's easier to prevent a problem than fix it later on. So if you're trying to save money on a project, it's easier to be careful in the early stages and avoid mistakes and save the money early on than it is later. Because early on, there's lots of options for saving money. Maybe you can make the building smaller, maybe you can choose more efficient air conditioning systems. There's lots of options for saving money, but the longer you go, you you lose a lot of the alternatives for saving money. Okay, the bulk of what we're going to do today in the in-class exercise has to do with something called the unit method. And the unit method is a way of estimating what costs in a project are going to be based on the things that go into the project. So you take the direct expenses and you multiply them by the number of units required. So for instance, if you know the cost of plastic per kilogram and you know how many kilograms of plastic it takes to make a mobile phone case, then you can find the total estimated cost of the item by adding up all of the components and multiplying it by the units. So this is done a lot in the real world. For instance, operating a car is often estimated to be around 52 cents per mile. Building a highway, the rule of thumb estimate for that is it's $6.2 million per mile of highway. Constructing a house, you can find a dirhams per square meter, dollars per square foot. The idea here is you have the unit cost, and then you decide the cost of the project by just multiplying how big the project is going to be by this unit cost. So if your apartment will be 100 square meters, and you know the cost per square meter, that gives you a rough idea, a very quick estimate of how much it may cost to construct. So here is the in-class exercise I'm going to be handing out. What we're looking at is two different problems. The first one is having to do with the installation of a gas pipeline. And you have all of the unit costs here you need to calculate the total overall cost. I've also told you an indirect cost that has to be added. And the indirect costs you add on top. It says it's an hourly rate and 400 hours required for the entire job, so that's just added on top of all the other costs as well. So I'll let you get started on this. Of course, it's fine to collaborate with your colleagues, and I'll be circulating around with the solution. I'd miss you guys too much. I think everyone has finished the first one. Let me give you a hint on the second one. On the second one, there's two different options. We're trying to do some decision making based on costs. One of the machines can make 57 parts per hour, and another machine can make, where is the, say the number, 102 parts per hour. So this machine is faster. The second machine is faster, but it uses more expensive plastic, right? So we know that each month we have to make 8,333. So the way you calculate the number of hours is by the efficiency of the machine. So this is the number that has to be produced. Here is the rate that it can be produced, 57.1 parts per hour versus 103 parts per hour. So that's how you calculate the number of hours that each of the alternatives is going to require. Yeah. So for the low grade, there's three things that contribute to the cost. There's the labor cost, the material costs, and then it just says the other costs. And yeah, here where it says the other variable costs are estimated to be $10 per hour. So what we need to do is the first step is find out how many hours is the factory going to be working if they have the low grade option. If they're using the cheap plastic, how many hours is the factory running? So the way we find out the number of hours the factory is running is we know the demand is 8,333 units per month. And this is our efficiency factor, the 57.1 units per hour. That's the rate that the machine can turn out the products. And so I think what that works out to is, this is 145.94. That's what you get when you divide the 8,333 by 57.1. That's how many hours per month the factory is running. And if we know that the labor cost is $15 per hour, that's where we get this. And then the other costs, you know, it may be the electrical costs. Yeah, it's probably related somehow to indirect. Then that is the $14.59. And then there's also the cost of the plastic itself. And that's the main thing that's different between these two processes is the high quality plastic is more expensive, but it's also taking less hours. And so what this option boils down to is we're trying to see, is it better to work more hours and pay more for labor, or is it better to save money on labor by using the high grade plastic and then have more expensive plastic costs? And so if we compare them, you can see that the labor is less for the high grade option, and so are the other costs. But the plastic goes from $88 per month to $448 per month. So the plastic's more expensive, but it's still worth it. The high grade system is worth it because you're saving so much on labor. And so it has the cheaper alternative. And then the last thing is asking what's the annual cost difference. And what we do there is just multiply it by, you know, if this was all per month, multiply it by 12 months per year. So you should be saving $15,000 a year if you switch over to the high grade plastic. The high grade has the lower costs, right? $2,400 per month instead of $3,700 per month. So the basic idea is you just choose the option that's going to be least expensive for production. Any other questions on this one? All right, well, I'll see you on Tuesday, but not on Thursday. Have a good one.